Hey everybody, good morning. Welcome back to lesson 3, the combined gas law. Now some of you might be wondering, why are we looking at Google Classroom? So I've had a few students who are getting a little bit lost in the stream on Google Class. So they're not knowing where an assignment is. There's just so many things in the stream that it's kind of confusing. So you should, in your Google Classroom, be choosing this option right here, Classwork. Okay, when you click on Classwork, you'll see that the Google Classroom is organized by folders. So here's our Chapter 4, Lesson 1, Lesson 2, and here's Lesson 3, today's lesson, on combined gas law. And they all appear in order. It's just a much better way for you guys to stay organized. So make sure you're choosing Classwork in Google Classroom as your option. And now I need to get out of here and back to our other lesson. Okay, so today we're doing combined gas law, and I would like you guys to follow along in your notes. This is a pretty short lesson. It's not going to take us very long to do, which is great. This week we are finishing off pretty much all of Chapter 4, Gas Chem. None of the lessons are super difficult. Today's is actually quite easy. So if you have a good understanding of Boyle's law and Charles' law, both sort of the theory behind them, those two different graphs, and then the math using the formulas, combined gas law is actually pretty easy. In fact, if you look at combined gas law, you will see that it is Boyle's law, P1V1 equals P2V2, and it's Charles' law, V1 over T1 equals V2 over T2. So it's both laws combined together into one super useful one, which allows us to solve any question, whether it's a change in pressure or volume or temperature, from situation 1 to situation 2. Now, before we go any further, I want to do a little bit of a review of algebra with you guys, because you are going to be rearranging this equation to solve for any one unknown. So let's say, for example, that we wanted to solve for pressure 2. So we want pressure 2 by itself. That means we need to get rid of V2 and T2. So how do we do that? Well, the algebra rule is, if you want to remove a variable from one side of the equation, you divide. If it's on top, you put this in. If it's in the numerator, you put the same variable in the denominator. And whatever you do to one side, you do to the other. Okay, so V2 is gone. I want to get rid of temperature 2. It's in the denominator, so I put temperature 2 in the numerator on both sides. And it's gone. Okay, so there's our new formula for solving for pressure 2 is temperature 2, pressure 1, volume 1 divided by volume 2, temperature 1. Okay, what if I wanted to solve for volume 2? Volume 2 by itself. How would we rearrange this to get rid of pressure 2 and temperature 2 from that side of the equation? Okay, pressure 2 on the bottom. Pressure 2 on the bottom, it's gone. Temperature 2 on the top. Temperature 2 on the top, and it's gone. Now the last one is the tricky one. And you really shouldn't memorize these. You should be able to rearrange and solve for any one of these. It's a very helpful skill, and especially those of you taking Physics 20 as well, where you're constantly rearranging equations to solve for one unknown variable. All right, if I'm solving for temperature 2 and I get rid of P2V2, my final answer will be 1 over temperature 2 equals. Yuck. That's not good. We want to solve for T2, not 1 over T2. So the solution to this is actually quite simple. You can use this in physics as well. If your unknown variable is on the bottom, you flip the entire equation. So I think I showed you the math this the other day. 4 over 3 equals 4 over 3. If I flip both sides, the statement is still true. So same thing here. I flip both sides. So now it's T1 over P1V1 equals T2 over P2V2. And now I want to solve for T2. So how do I do that? I just have to get rid of P2V2. Put them on top. P2V2. P2V2. and they're gone. Now I can solve for temperature 2, and there's my formula, P2V2T1 over P1V1. So these are the manipulations we're going to be doing today with the combined gas law, and we're going to solve 3 questions. So it's one of the shortest lessons. Okay, one more piece of information. Sometimes one of the 3 variables does not change. It's a constant. So if it's a constant and it's the same on both sides of the equation, it can simply be eliminated or canceled out from the equation. So let's say that we were going to keep temperature constant. So we had a gas at 43 degrees Celsius and it stayed at 43 degrees Celsius when we changed either the pressure or the volume. So if temperature was the same on both sides, it's not changing, it could be removed. And that would be our new formula, which is just Boyle's law. Okay, what if I was going to keep the volume constant? And that's pretty typical in questions where you have a steel cylinder which can't expand or contract like a propane tank. Its volume is constant. So if the volume is constant, it's the same on both sides, we can just cancel it out. That would be our new formula for solving for a gas when either the pressure or the temperature is changing, but the volume is constant, which is our first problem. A steel cylinder with a fixed volume. So that means we're using this equation. And what are we solving for? Okay, let's see. We've got a pressure and a temperature. Those go together. So we'll call those pressure 1, temperature 1, temperature 2, and we're calculating the new pressure. So we're looking for pressure 2, question mark. So you can label them in the question or you can write them off to the side. Pressure 1 is 652 kilopascals. Temperature 1 is 25 degrees Celsius, and we need that in Kelvin. For gas chem, everything is in Kelvin. So that's 298 Kelvin. Temperature 2 is 150 degrees Celsius. Plus 273 is 423 Kelvin. Okay. And we are looking for pressure 2, question mark. Okay, I need pressure 2 by itself. So I get rid of temperature 2 by putting a temperature 2 on the top, on both sides, and those cancel out. Okay, so there's my new question to solve for my new formula. So does that make sense to you, Kendall? Danielle, any questions? Nope. Okay, Bella, you're good. Megan, thumbs up. Okay, so now we just have to substitute in to our new formula. Pressure 2 is temperature 2, there's temperature 2, 423 Kelvin. Pressure 1, let's go a new color. Pressure 1, there's pressure 1, 652 kPa. And it's divided by temperature 1. And there's temperature 1, 298 Kelvin. Okay, Kelvins cancel out. Plug that into your calculator and you get 925.4899. And our units, kelvins cancel, kilopascal, that makes sense. We're solving for pressure 2. And sig digs, 3, 3, 3. So our final answer is 3 sig digs, 925 kilopascal. How awesome is that? So that's combined gas law. We'll do 2 more questions. Okay. A cylinder of gas has a volume of 2.2 liters. So we'll call that condition 1. It's at this pressure and this temperature. What would be the new volume? So we're looking for volume 2 if it's at this temperature and this pressure. So SATP, you don't have to memorize it. You can look it up, which I'm doing right now on the back of my Chem 20 periodic table, the data sheet on the back. SATP is 25 degrees Celsius and 100 kPa. So that's pressure 2, temperature 2, and we're looking for volume 2. Okay, so combined gas law, P1 V1 over T1 is P2 V2 over T2, and we're solving for V2. So I need to get rid of pressure 2, put it on the bottom, cancels out. Get rid of temperature 2, put it on the top, and it cancels out. So we are left with volume number 2. We got to do some conversions of our temperatures. So 200 or 25 plus 273 is 298 Kelvin for temperature 2. Temperature 1 is 30 degrees Celsius, which is 303 Kelvin. Okay, so I have temperature 1, temperature 2, volume 1, pressure 1, pressure 2. Holy smokes, what a mess. Values all over the place. Now, some of you I know that's going to drive you crazy. You're going to want to write them neatly off to the side. Volume 1, temperature 1, pressure 1, temperature 2, and pressure 2. Now they're nice and organized. Excuse me, I can substitute them in. So here we go. Temperature 2, 298 Kelvin. Pressure 1, 800 kPa or kilopascals. Volume 1, 2.2 liters. Divided by temperature 1, 303 Kelvin, times pressure 2, 100 kilopascals. When you're entering this into your calculator, make sure that you multiply the entire numerator. When you hit enter and get your answer, then you can divide by the bottom. Most important is that you put brackets around the denominator so that these two get multiplied together before they get divided into the numerator. If you do that correctly, you will get 17.309 liters. And we have our limiting factor is this one for sig digs. 2 sig digs means 17 liters is the correct answer. Hopefully you're going, yes, I got this. This is easy. Okay, last example. All right, so we have a balloon containing helium gas at 20 degrees Celsius, temperature 1. There's our pressure 1, 100 kPa, and there's our volume 1. So here's our balloon starting out at these conditions. This is the story of you at the carnival, the circus, at what do we call it in Red Deer? The summer festival, something days. Oh, I can't think of it. Klondike Festival in Edmonton, Stampede in Calgary. You're a little kid, you got a balloon in your hand, and you let it go, and it's helium, and it rises, and it rises, and rises 10 kilometers into the upper atmosphere where it's very cold, and there's very little pressure. So what happens to the volume of the balloon? Volume 2. What happens to that balloon when it rises 10 kilometers into the atmosphere, and it has a very cold temperature 2 and a very low pressure 2? Does it get smaller or larger when it cools down and the pressure is lower? You could make your prediction. Now I'd like you to try this one on your own, and then, so pause the video, try it, and then come back and see how you did. All right, so P1 V1 over T1 equals P2 V2 over T2. We're solving for V2, so we're going to get rid of pressure 2 and temperature 2. Okay, we have V2 on its own. So V2 equals temperature 2. Where's temperature 2? Minus 36. We need to convert that to Kelvin. So we're adding 273, and that gives us 237 Kelvin. I don't know why I'm using such a light color. Let's go red. Okay, so that's temperature 2, pressure 1. Pressure 1 is 100 kPa. Volume 1 is 7.50 liters. And in the bottom in brackets is temperature 1. There's temperature 1, 20 degrees Celsius plus 273 is 293 Kelvin. Okay, so far so good. Any questions, Lloyd? Nope. Awesome. Blake, you're good. Justin, you're loving this, aren't you, Justin? It's all math. Okay, 293 Kelvin, and pressure 2 is 28 kilopascals. Now I'm going to cancel out some units here as well. Kilopascals with kilopascals, Kelvin with Kelvin, and we're left with liters on top, which is what we're looking for. So that's good. And we get 21.6 repeating. Sig digs, 3, 3, 2, 3, 3. There's our limiter, 2 sig digs, 22 liters. Ba-da-da-da-da. I'm loving it. Buck teeth and all, I'm loving it. 3 baby hairs. Okay, so hopefully you're finding this really easy. A confidence builder for you. Whoops, here's what I wanted. In your study guide, there's 2 worksheets you can do. This one on page 158 and this guy on page 160. They're both good. I'm going to put answers on the Google Classroom for you so you can check to see how I'm setting them up, that you're getting correct units, correct sig digs. If you want additional practice, you can do those guys in the textbook. Answers are on page 783. Not solutions. Doesn't show you how to get the answer, just the correct answer with correct sig digs, correct units. So that's today, Monday, and then we're going to do, well, you've seen the weekly schedule I put in Google Classroom on today's lesson. Hopefully you took a look at that so you know where we're going this week. We're pretty much wrapping up the chapter. Today's actually Saturday. I'm recording this, so it's ready to go for Monday. And I'm going to go for a ski this afternoon. Hopefully you watched my ski video and you were inspired to make your own video to show me what you're doing in your free time to stay sane, be happy, be healthy, as we work together to get through this most challenging time. Okay, take care, everybody, and I will see you again on Tuesday.